Good morning, welcome to One Concept Per Day portal. And today we are going to discuss about a concept known as Coulomb's law. Okay, Coulomb's law questions are very simple. There we have only something like the force acting between any two charges, and then we are going to determine what is the force. That's what we usually learn in the class. But now I am going to depict you a question which is totally different. It has a lot more number of information that one can extract from Coulomb's law. Okay, let us start with this question. So this question is taken from November 2005 paper. So the first question reads something like this. Yeah, it's about an electrostatic experiment to investigate the force between two charges. A small charge sphere S hangs vertically from an insulating thread as shown below. Okay, there's a insulating thread over here. There's a charge sphere which has been hanging over here. And then a second identical sphere, charge sphere P, is brought nearby closer to S, and S is repelled as shown. So you're bringing it nearby, it gets repelled like this. So there is a repulsive force acting like this. So the sphere which was initially like this, okay, now gets repelled like this and goes over here. Okay, now the magnitude of the electrostatic force on the sphere S is F, and the separation between the two spheres is R. So as a result of this, separation is R, this is force F over here. Okay, so easily we can say, okay, this is charge Q1 and this is charge Q2. So there is a repulsion being seen. Okay, then next is on the axis below, draw a sketch graph to show how, based on Coulomb's law, you would expect F to vary with 1 by R square. Okay, so now you need to plot a graph of F versus R square. Now towards it, a small charge sphere S. Okay, so this has a charge Q, a second identical charge sphere. That's why I read this once again. Second identical charge sphere, which means what? You see, this Q1 should be equal to Q2, or maybe I can write this is Q and this is Q over here, and this is R. This is R. You need to plot a graph of F versus R, which means what? If I change the value of R, the value of F will also change. Okay. Now what is supposed to be added? 1 by R square versus F. Now what is the relationship connecting F and R? We know that Coulomb's law tells you that F is equal to K Q1 Q2 divided by R square, right? So that Q1 is equal to Q2. So I'll write this as K, Q into Q becomes Q square divided by R square. Now what is he asking? Plot a graph of F versus 1 by R square. Now what I will do is, let us look at what is there along the x-axis. Along the x-axis it's 1 by R square. So I will just substitute this as, I'll take KQ square, and this 1 by R square I'll write this as X. And along y-axis this is F over here. Okay, so therefore for F I will replace this by Y over here. So therefore now I have an equation like KQ square into X. Q is constant, K is constant, so whole thing is constant. So this equation resembles Y equal to mx, right? When you say Y equal to mx, then what kind of plot will I get? I will definitely get a straight line. Okay, so therefore I will get a straight line. And how does the straight line? It passes through the origin because the intercept is 0. So definitely it has to pass through the origin like this. Pass through the origin. Now what is the angle made by it? That depends upon the value of the slope. You may write this as 45 degree, 30 degree, 60 degree, whatever it is. Okay, so I'm not going to comment on it. I'm just going to write like this over here. And I can now say slope is equal to M, which is equal to KQ square as seen from the equation. See? So this is what we have got. Okay, let us write that also. Though this is for 2 marks, we cannot just stop it over here. We need to write this also whenever we write a straight line equation. Okay, next. Values of F are determined for different values of R. The variation with R 1 by R square of these values is shown below. Estimated uncertainties in these values are negligible. Okay, so it is shown over here like this over here. Okay, and then draw the best fit line for these data points. You need to draw the best fit line. So what is the difference between this graph F versus 1 by R square and the graph that I have drawn? Both are one and the same. Okay, only thing is there are some scatter plots there, and I have no points over here. I have just drawn a straight line over here. So what are the features which are very similar? The similar is that, okay, these points should seem to be joining the origin. The line should be drawn in that way. Okay, so now what we do is, let us go back here. Now there are points over here. See to it that I draw a line which connects this point and this point. Almost it connects every point. Draw a line like this. Of course, I am just neglecting that line. Maybe it should be touching this because I don't have a scale. I cannot draw it using a scale. I am drawing it like this over here. Okay, then next. Okay, question number 2. So use the graph to explain whether in the experiment there are random errors, systematic errors, or both. What kind of errors do we have? Let's look at the graph here. See, there are points given here 1, 2, 3, 4, 5, and this point is a little bit away from this. Maybe even if I use something like a scale over here to plot it, okay, even then, do I have a, let me just find out. I don't have any tools to draw a straight line using the scale. If I had, I would have shown you here. So what kind of graph it is? Okay. So still I can see that first thing is it is not passing through the origin. Okay. And second thing is that you see the errors are all a little bit higher as compared to the straight line over here. Okay. So thus I can say there is a systematic error. It's a systematic error. Okay. So if it passes through the origin, then it's fine. Okay. There's no error over it. But first of all, it is not passing through the origin, and every point is at least this much amount of distance. Okay, if you draw a line of best fit, so as a result of it, I can only say that this is a systematic error. Now, why is it not a random error? If you ask me this question, a random error, I can answer it provided that, okay, let us say this point is here, this point is here, this point is somewhere over here, this point is somewhere over here, this point is here, okay, and this point is somewhere over here, and so on. In that case, I can say they are randomly being placed. So it could be a random error. So this is not a random error, it's a small systematic error being observed. Okay. If not, what would I have seen is that I could have got a line like this actually. I should have got a line like this over here. Okay. So this should have been the correct line. But you see, every point is being displaced by the same amount from this line. So therefore, you can definitely say it is a systematic error. Okay. Next, let us move on to the next one. Calculate the gradient of the line drawn in B1. Oh my god, we need to draw. Okay, let me just remove this line so that I can draw a clear line over here. Or maybe I can draw the gradient. Otherwise, there will be a lot of confusion here. Let me remove this line. Right. Now, where do I draw here? I will take up some point over here. I'll take up this point, and this is what is this? This is 5 here, and I will take up let us say 2 here. This point over here. Draw a triangle over here. Let's see. Now, what do I need here? It says calculate the gradient of the line. Gradient. What is the gradient here? This is your delta f, and what is this over here? This is your 1 by r square. Delta of 1 by r square. Because we need to know what is it about, right? So therefore, gradient here. Let us draw the gradient. Gradient is equal to delta f divided by delta of 1 by r. Don't do any math over here. Just calculate the gradient. What is this value here? This value is nearly 5, and this is 2. 5 minus 2 is 3. 3 Newton. 3 into, there is some multiple here. 3 into 10 power minus 3. So I have to write that as 3 into 10 power minus 3 divided by delta of 1 by r square. What is that value? This value in terms of how much? 10 power plus 3. 10 power plus 3. What is this value here? This value could be, if this is 6, this is 7. 7.2, 7.4, so on. This will be 8.4. This value is 8.4 into 10 cube, and this value is 3 into 10 cube. Okay. Now let us write down 8.4 minus 3 should be 5.4 into 10 cube. Right. So this should now be equal to. Let me use my calculator. This should be 3 divided by 5.4 will be 0.55. 0.55 into 10 to the power of minus 6. Okay, Newton per 1 by r square. This is meter square. When it goes upwards here, this will be per meter square. When it goes upwards, it will be Newton meter square. This should be the answer. Okay, let us write down this answer. What is the answer I got? 0.55 in 10 power minus 6. So I can now write this as 5.5 into 10 to the power of minus 7 Newton square meter. Okay, next. The magnitude of the charge on each sphere is the same. Use your answer in B3 to calculate this magnitude. You need to find out what is the charge value. we already found the slope. Now what we do is, we know slope is equal to delta f divided by delta of 1 by r square. 1 by r square. Now we know that f is equal to k q square by r square, right? Now what is this now? This is nothing but slope. So what I'll do is I'll write delta y divided by delta x over here. So now this is your y. This should be equal to k q square into x over here. So therefore, this will be your slope. So whatever value I found out over here is nothing but k q square. So now I have k q square is equal to 5.5 into 10 to the power of minus 7. That's what we have, right? Let me check it out once again. 5.5 into 10 to the power minus 7. So therefore, q square is equal to 5.5 into 10 to the power minus 7 divided by 9 into 10 to the power 9, right? K value is equal to so much. So which we will calculate it once again. So it should be 5.55 divided by, I'll just cancel this. 5.5 divided by 9 will be 0.61. Right, this is 0.61 into 10 to the power of minus 7 here, minus 9 here. When it goes upwards, it becomes minus 9 here. Minus 9, minus 7, minus 9 becomes minus 16 over here. Minus 16. So therefore, the value of q will now be equal to, let us take only the square root of this. Okay, 10 to the power minus 16 I can easily take. When I do this, I get the answer 0.78 or nearly 0.8. I can now write this as 0.8 into 10 to the power of square root of minus 16 is minus 8. Minus 8, this should be 8 nanocoulomb. 8 nanocoulomb. Okay. So we have got the charge. Use your answer to calculate this magnitude. We have got the value of the each of this charge to be 8 nanocoulomb. Then explain how a graph showing the variation with log of r of log of f can be used to verify the relationship between r and f. Now once again what we do is write f is equal to k q square divided by r square. Let us take log f on both the sides. Log f is equal to log of kq square minus log of r square. Why? Because it's a by b form, right? It should now be equal to log of kq square minus 2 log r. This is what we have. Now he's asking you, using a graph, how do you find out this? So what can I do? I can now consider log of f to be y, and this to be c, and this to be log r to be x. This 2 will be m here. So I get an equation like y equal to c minus mx. What is y equal to c minus mx? Or maybe I can write this as minus mx plus c. What is minus mx plus c? This is also a straight line curve, straight line equation. Okay, and we can plot a graph of y. What is y here? I'll write log f, and this will be log, what is this value m x over here, like log r. And what kind of graph will I get? I will get a graph which has a negative slope and will also have an intercept like this. Okay, so I will get a graph which has a negative slope like this and will have an intercept like this over here. So this slope would be equal to minus 2. Okay, which means what? What is m here? M is nothing but minus 2 over here. And then this c, what is c here? This value is c. This value is c. This value is c, and the c will be equal to log of k q square. Now what is the question? We have already done everything. Explain how a graph can be shown the variation log r versus log f can be used to verify the relationship between r and f. So when you plot a graph of, how much marks is this? This for 3 marks. So when you plot, now finally you need to write something. Okay, when you plot a graph of log r versus log f, we should get a straight line. With the slope is equal to 2 and intercept is equal to kq. When we are getting this one, then definitely we will find out what is the relationship connecting this two, and it is correct over here. Okay. With this we come to an end to the first question. We will see the next question in the next video. Thank you.